Welcome to the Calculus A section. This is the last section that we will be discussing for Calculus A. Hopefully up to this point you have a genuine understanding of how to apply calculus to mathematical situations and are able to derive functions and find maximum and minimum values as well as relate rates and optimize functions. Now, in this section we'll be discussing Newton's method, which is not directly related to any of the previous sections but is an application of tangent lines. Let's suppose that we wanted to approximate the solution to f of x is equal to 0. And we were somehow given an approximate situation or solution given x naught. This initial approximation is very far off, or at least not where we would like to be. Therefore, we will find a better one. So let's look at the line tangent at x naught. We can say this equation is represented by f of x is equal to f of x naught plus f prime x naught times x minus x naught. Now, let's look at our animation. We know that at one point, x of 1 has a coordinate x1, 0. So if we plug that into our equation, we can say that 0 is equal to f of x naught plus f prime x naught x1 minus x naught. Therefore, x1 minus x naught is equal to negative f of x naught over f prime of x naught. Now, this is our Newton's method. However, we have a general equation that is written. We can say that x of n plus 1, meaning the next, say in this situation our x2, we can say is here. The next step equals the prior step minus the prior step's function over f prime x of n. Now this process can go on for a very long time, if not an infinite time. Therefore, a general rule of thumb is to stop after two successive approximations are synonymous up until a given number of decimal places. So let's say we wanted to determine the Newton's method of f of x is equal to x cubed minus x plus 1. Now first we would need to find the derivative of our function. So we can say f prime of x is equal to 3x squared minus 1. Now with our initial value at x naught is equal to negative 1, we can clearly state that f of x is equal to xn minus x cubed n minus xn plus 1 over 3x squared n minus 1. Using this, we can compute that f of x is equal to x naught minus x cubed naught minus x naught plus 1 over 3x squared naught minus 1, and f of x is equal to xn plus 1. Therefore, with x not equaling negative 1, our x of 1 is going to actually equal negative 1.5. Our x of 2 is going to equal negative 1.347826. Our x of 3 is going to equal negative 1.3252. Our x of 4 is going to equal negative 1.324718. Our x of 5 is going to equal negative 1.324717, which is very close. And just for security, we're going to do x of 6, it's going to equal negative 1.324717. Therefore, our root is going to be x of 6, or negative 1.324717. I hope that helps, and if you need more assistance, the website has a bunch of help.